TPI that Storm Shield offers has multi-dimensional protections for both networks. OT and IT protections are built within the DNA of Storm Shield API. The need for IT protection within OT networks comes from the fact that OT communications are on the base of IT communications. For example, OT protocols such as Modbus is within a TCP set and is subjected to all types of TCP/IP attacks. Storm Shield is continuously optimizing the software architecture and TPI algorithms to deliver the maximum shield of security and best performance. Storm Shield packet inspection performs multi-dimensional analysis of all types of communications. Each packet is being analyzed by protocol-conformity whitelisting check, anomaly detection based on heuristic and statistical analysis, and match against intelligent contextual signatures, which perform a detailed operation and filtering content. In parallel, internal access reputation scoring is being calculated every 15 minutes to build internal hosts baseline. The traffic is also scanned for known applications, operating systems, and vulnerabilities with the ability to disarm malicious content instead of all block. Storm Shield Next Generation Firewall offers a wide range of security and control mechanisms that are independent of deployment modes. Storm Shield Next Generation Firewall can be deployed either in line, transparent, routed environment, or in a mixed hybrid environment. The flexibility of Storm Shield Next Generation Firewall makes it easy to create safe and secure zones, and also simple to deploy in complex architectures without the need to modify anything today. Storm Shield Management Center is the perfect solution to manage large-scale Storm Shield Next Generation firewalls and its deployment and establishing security and double-trusted Storm Shield Next Generation Firewall also offers an API integration for the ease of integration with third-party solutions and existing ecosystem. SNI-40 is Storm Shield Next Generation Firewall plugin model. It's an industrial-grade firewall adapted to the environment. All Storm Shield Next Generation Firewall models offer integration without modifying the existing operational infrastructure. SNI-40 is suitable for large operating environments with high performance and low latency. It's the right solution for time-critical operations. Supports safety bypass and global log storage on SSD drive and 1 gigabit per second copper and fiber port interfaces. SNI-20 is the recent runtime model for a Storm Shield Next Generation Firewall panel. Same as SNI-40, it offers integration without modifying the existing operational infrastructure. SNI-20 is suitable for harsh operating environments and electromagnetic interference. High performance and low latency safety bypass and logs can be stored on the SD card. Supports 1 gigabits per second copper and fiber ports. The average throughput of TPI within market deployment firewalls is close to 400 megabit per second. The two rugged models from Storm Shield SNI-20 and SNI-40 provide the highest TPI throughput, where SNI-20 at 1.6 gigabits per second, 4 times the average, and SNI-40 at 3.3 gigabits per second, 8 times the average. At cost-effective price, the ROI with Storm Shield Next Generation Firewall is the highest in the market considering TPI throughput. Storm Shield Next Generation Firewall offers built-in interactive visibility to automatic and real-time traffic monitoring. Monitor real-time with graphical user interface tools, live traffic, alarms, visibility of applications, and vulnerabilities. They take direct actions from the interactive. Supported by help pages to every alarm and detected vulnerability, provide technical details and references, and administrators can take the right decisions to secure their networks. Storm Shield. Some security.
ครับสวัสดีครับทุกท่านนะครับก็เข้าใจว่าท่านน่าจะพอทราบข้อมูลอินโฟร์ชันของตัวงานวันนี้แล้วนะครับว่ามีอะไรบ้างก็เปิดวนกันอยู่หลายรอบพอสมควรครับโดยเฉพาะอย่างยิ่งท่านใดที่เข้ามาตอนแรกๆนะครับก็น่าจะบอกกับ15 นาทีนะครับก็ขอแนะนำตัวนิดนึงครับผมธีรพัฒน์นะครับผมเป็น Product Manager ที่อยู่บริษัท ITT สังกัดมหาชนนะครับ ITT ก็เป็น Distributor ของ BIZsecure นะครับ ก็โปรดักต์ไม่ว่าจะเป็นตัวนี้ครับคือเซ็ตแบบกองคิวแล้วก็อีเวนต์ครั้งที่ก่อนหน้านี้ครับก็มีการจัดหลายท่านก็น่าจะเข้ามาจอยพอสมควรนะครับก็น่าจะรอสัก10 ท่านเข้ามาจอยนะครับวันนี้ก็เป็นอีกหนึ่งโซลูชันนะครับที่เป็นโซลูชันเฉพาะสำหรับในกลุ่มอุตสาหกรรมโดยเฉพาะฝั่ง operational technology นะครับอาจจะไกลตัวเรานิดนึงนะครับเพราะว่าก็แบบที่เราทราบกันเนาะเทคโนโลยีมันเริ่มหลอมรวมกันทั้งฝั่ง IT บ้างฝั่ง OT บ้างนะครับวันนี้ก็เลยมีการจัดเซสชั่นคือความร่วมมือกันระหว่าง IT กับ BIZsecure นะครับแล้วก็วันนี้เนี่ยเราได้รับเกียรติจากเวนเดอร์จากสิงคโปร์ที่จะมาช่วยนำเสนอตัวโซลูชันนะครับที่เกี่ยวข้องกับ OT Security นะครับก็จะมีเป็นโปรดักต์2 ตัว SecLab นะครับเป็นคล้ายๆกับตัว Data I/O นะครับที่เรารู้กันเพราะว่าทำได้มากกว่านั้นนะครับแล้วก็อีกตัวนึงคือมีการ integration ร่วมกันระหว่างตัว SecLab ที่เป็นทำเกี่ยวกับเรียกว่า Data Certification นะครับเดี๋ยวเราคงได้รู้ว่าคำว่า Data Certification เนี่ยมันคืออะไรนะครับไป integration ร่วมกันระหว่างตัว Firewall ที่เป็น OT ที่มีโปรโตคอล OT เป็นบล็อกเล็กๆประมาณนี้นะครับจะเป็นลักษณะดูเร็วนะครับก็เซสชั่นตัวนี้มันประกอบด้วยประมาณ3 ส่วนนะครับเรื่องของ introduction น่าจะเป็นรายละเอียดที่หลายๆท่านได้ดูวิดีโอเข้าไปมันจะเป็นมิสเตอร์ตัวเป็นคนที่นำเสนอในรายละเอียดนะครับแล้วก็ต่อมาเป็นเรื่องของ security on OT นะครับว่าหลังจากที่ตัว SecLab กับตัวStorm Q Integration เป็นอย่างไรบ้างนะครับแล้วก็โซลูชันสุดท้ายก็จะเป็นเรื่องของเป็นโซลูชันหลังจากที่ Integration นะครับร่วมกันในลักษณะเป็นไลฟ์เดโมให้ทุกท่านดูว่าการทำงานร่วมกันเป็นแบบไหนยังไงนะครับซึ่งพาร์ทหลังในที่อยู่ในเซสชั่นหลังจากเบรกนะครับก็ประมาณหลังจากนั้น 11 โมงกว่าๆครับหลังจากเราเบรกแล้วก็กลับเข้ามานะครับตอนนี้ก็เดี๋ยวขอเชิญคุณตัวแล้วกันนะครับในภาพรวมงานนี้ครับขอบคุณครับ
Okay, so thank you again for joining us today. Sorry, I'm going to speak in English. So Sarah is going to give you some key points inside later on. Again today, the main topic of this conference, of this meeting, is to talk about cybersecurity in OT and to understand, of course, what are the challenges, what is available today to protect correctly and to protect, to secure your OT environment, and technically speaking, to understand again everything about what you can find and the risk inside it. So, again, is industry ready? And we're going to, I'm going to explain exactly what we mean by that. So again, for myself, I'm Tuan, and like was mentioned, we're going to go through a very quick introduction about industry in general. Then we're going to talk about more specifically about the cybersecurity in the industry. We're going to go through solutions which are functional at SecLab, why they are the solution of choice, and how these two solutions can help you in securing, protecting your OT environments. It's not written here, but we will have a break, and then we will go through the demonstration to show you how it looks like and how it works. So, in regards to the introduction, so again, today, when we talk about industry, how it works, and so on, you will tend to see on the internet people talking about Industry 4.0, what we call Industry 4.0. So what is Industry 4.0? People tend to say that, okay, it's just, buzzwords, it's marketing, it's not real, but actually, we can see more and more deployment and more development over Industry 4.0. So Industry 4.0 is what we call the ongoing automation of traditional manufacturing. and industrial practices using modern and smart technology. So what does it mean? Okay. When you go over Industry 4.0, when you tend to go over the Industry 4.0 model, you will have 4 principles to move over a simple Industry 3 to Industry 4. The first one is what we call the interconnection, right? So what does it mean? It means that in an Industry 4.0, everything will be connected. So from the simple IoT device, like a turnstile, like a camera, IP camera, like a gate, anything is going to be connected to different types of systems. For the alarm, the locks, for checking the events, checking the status, everything is interconnected. The second thing is the transparency, right? What we call by transparency is the ability for all the systems to see effectively what is the status, what is the how does it work, and how they communicate together. The third one is what we call the technical assistance. So technical assistance is the ability for an expert, an engineer, to come over a system. Again, it can be an IoT device, it can be an OT device, so for example a PLC or anything, and have the ability to manage it, configure it, and that if it is needed, of course. But at the same time, you also have what we call the decentralized decision, which is the ability as well, if configured correctly, to let the devices make choice by themselves, depending on is the status is green, is the status is red, what do I do? So you let the choice through Industry 4.0. You have the ability to say, okay, this is my policy, my security policy. If, for example, the temperature is too high, then automatically drops down. If the water level is too high, then automatically close the gate, for example. So there's a lot of different things again that makes it different between, of course, the old model of Industry 3.0 and then the Industry 4.0. So again, I can say interconnection, mass connectivity, of course, smart device. Again, I talk about OT, but like I said, same thing for IoT. So smart devices. And then we have seen more and more computers inside an OT environment. So computers in even the smallest devices. So for example, watch, right? Now you have smart watch, you have smart building, you have smart everything, smart car, smart TV. So of course, you have connections in all of these items. So for the transition between 2 to 3, it was easy in the sense that they added a new system, which were the computers. Computers in Industry 3.0. So it was a completely different technology. Between the assembly line, with all the classic mass production, the electricity and so on, when they come from 2 to 3, they implemented computer. And from here, it was completely different. So, okay, new technology, but from 3 to 4, we're still using computer, but differently. And again, this is where you will have problem, of course. So because today, as we are not thinking the same way as in very long time ago, of course, now we have again a different way of thinking, we have a different way of working as well. So we have to come up with different type of attacks that were not previously in the Industry 3.0. So as a result, again, you have new risk, you have new vector of attack, you have new problem. And let's take some example. It concerns all industry, whether you're in oil and gas, in power, so electricity, in the pharma, in automotive. You will have different problems, depending on your industry. But the common thing is that you will have problems. So, just some example. The average cost of a cyber attack in the oil and gas, 12.8 million USD average. In the electricity, 11.5 million USD. So as you can see, there's of course there's a very high risk and it's a very high cost for staff. So that being said, again we know that the OT is changing, OT environment with IoT devices, OT devices. You have now SCADA systems, you have a lot of different things. So that being said, okay, the industry changed, but are we sure that we are ready in terms of cybersecurity? Do we have, well, the processes? Do we have the solutions? Do we have the technologies to be able to protect? What we need to understand is that, yes, industry has changed a lot. It has changed through the time, and again, it is changing today. But what we need to understand is that between IT and OT, of course, IT is evolving much more faster. There's no competition here. So for the IT, for example, you can see maybe every 2-3 years, maybe 5 years, you're going to change systems, firewalls, switch, routers, maybe. In the OT, 20, 25, 30 years. So it makes, of course, the cybersecurity very difficult because of that. Because you have to have something, you have to have solutions, you have to have an environment that will not change a lot. And you still need to be able to protect, secure. So again, the industrial tools, they have their own place, like I said, making connections between the various active components, basically what we call the filters. And again, it's survived through today in Industry 4.0. But what changed is, again, how we use these filters, how the systems inside the OT use these filters. So, again, what is important is that when you talk about IT and when you talk about OT, again, it's completely different. We already know. Here again, what you have to understand inside an IT network, a classic IT network, is that you have lots and lots of data, of course. You have a lot of information going on, and that's what it's designed to do. You have this kind of usage, classic usage inside an IT environment. So you have data coming from, for example, your data center, your domain controller to the workstations. You have a lot of different workstations. You have antivirus sending information to endpoints. You have a lot of things inside IT. In OT, difference is that, of course, you don't have all that, or very much less. In OT, generally, what you have in OT networks, what goes through in OT networks? In OT networks, what you have usually are commands. Goes up, goes down, right, left, on, off. That's usually what you have in OT. Right, because you're trying to control like buttons, you're trained to control simple robots, you're trained to control sensor. So it's not intelligent, if I can say. It's not smart. It's just very, very basic, very, very simple. So everything that you set inside an OT network, by nature, is very, very simple. The other point, of course, from an OT point of view, is what we call the singular management. So, like I mentioned already, with Industry 4.0, everything tends to be connected, and even connected from IT to OT. More and more, we can see IT being connected to OT. And we can even see, in some cases, OT to the cloud. It happens. Not that much, but it happens. So, what we have is that until Industry 4.0, we have no need for example, a manufacturer or an industry to have management, to have a control outside of the OT environment. Until now, we need. You have a site, you have a manufactory, local network inside the manufactory, that's it, nothing else. But again, today, you have the manufactory connected to management center, monitoring center, and it's going to be more and more common. So again, in the past, this kind of network, they are operating independently. Again, there's no connectivity outside, there's no. So independently of one another, and very little exposure from the cybersecurity. If you cannot even physically access to the network, how do you have? You know? So from the OT perspective, from the OT vision, they say, okay, I don't need cybersecurity. Why? Because I'm not even connected. If I'm not connected, why do I need cybersecurity? But again, of course, everything is changing. And there is a very, very important point, even more today, is that besides the environment, besides the network, the security, the cybersecurity, there is a very, very important thing that everybody needs to control, needs to manage, and it's going to be the same thing everywhere, in any industry, even in IT. The most important is people. We can have the best firewall, the best data layer, the best gateway, everything. If you have someone that has, for example, different privileges, the accesses, physical access, direct access to a critical system, if you can't trust the people, your security is useless. It's going to be always the same. So, there's a lot of things to take into consideration when you have this kind of environment. So, that being said, for the OT, because in, I would say, the classic way, IT and OT are completely separated, you also have people in IT as IT administrator and people in OT as OT administrator, but they're completely different usually. So they, of course, when we connect IT and OT, we also have to connect these two types of people, the IT administrator and the OT administrator, but they don't work the same way. So it's also very, very complicated to adapt in this situation. And so means that, technically speaking, whether you want to have a security policy policy in IT or OT, or if you want to have a global policy, it's going to be more and more difficult, of course, because again, it's two completely different environments. So, I didn't come up with that, but what was created by the NIST is what we call the ICS architecture. So the ICS architecture, you have 5 levels. You have the level on the IT side, and you have the level on the OT side. So, okay, what's inside? First, level 4, the highest. Okay, we are in IT. You have finance, accounting, logistics. It's technically the IT. Okay. Then, what do you have? You have the level 3, where you go into the plant. At this stage, it's not technically a machine, it's not robots yet. You will have what we call the management of the manufacturing. So you have management, logs, industrial process management. Okay. Then you have the level 2, which is the creation of process order. So at this stage, you have what we call the supervision and control. Level 1 is the PLC. So programmable logical controller, where you have the regulation and automation of the system. And then the lowest, level 0, with sensor and actuator, is where you have the system that works. The real system that works, so robots again, different sensors, temperature, level, anything. So this, of course, if you respect it, then first, very good. But what we need to understand is that the lowest we go, the hardest, or let's say, the most painful it's going to be in terms of attack damage. Because of course, if you attack level 4, let's say the accounting, okay, you're going to attack the accounting, you're going to hack into someone's laptop, you're going to retrieve some files. Okay, it's painful, but still can manage. But if you go here and you shut down a machine, if you shut down a pump, if you shut down a robot, then the manufacturing cannot work. Cannot do anything. So the lowest you go, the more damage you will get from an attack. So that being said, let's take an example. Okay, something that happened. When was it? Last year, 2 years ago. Let's take an example and see. Okay, if I attack this level, then what happens? Maybe you have heard of that. It's what we call Ripple 20. So what do I have here? I have what we call an infusion pump. You know, it's what you have in the hospital when you're on the bed and they put some fluids, some medicines inside here. Okay, that's infusion pump. Second thing is a printer, classic printer. Okay. And the third thing is a UPS device. So, Ripple 20, what is Ripple 20? Ripple 20 is 19 vulnerabilities that they found in very, very common OT devices. Very common. Rockwell, Schneider Electric, almost all of them. HP. So, with Ripple 20, what you can do is that execution. So from a single command that you have here, okay, you cannot really see, but from a single command, you can shut down everything. Lights, plug, printer, the UPS device, you can shut down everything. Of course, you can do that if it's not correctly protected, if it's not correctly secured. That's the main point. But still, again, if you are in an OT environment, which is much more, generally speaking, much more open than an IT environment, this can happen. Someone have the ability to access, send a command, and shut down your entire manufacturing. Okay. So let's imagine if that's happened in a real hospital, right? Someone wants to get money from the hospital, with the COVID happened a lot in France. In France, when the COVID arrived, all the hackers, okay, I'm going to hack hospitals. They don't have money, but I'm still going to hack. It's going to make me money anyway. So yeah, very, very important. That's only one example. Of course, the main example, the main attacks that you may know are things like Stuxnet. What was it? There was a lot from Stuxnet child. So, but again, of course, the main one was Stuxnet. But this is a very recent example. This is a very recent one. Again, last year or maybe 2 years ago. Yeah, so that's really what you can do. So today, when we say, okay, is industry ready for cybersecurity? Well, as you can see, not really all. It depends on what you have at disposal, what you can achieve and what you can implement. So there's of course a lot of different things, but again, to the main question, is industry ready? We can say yes, if you use the right solutions, if you use the right tools to help you protect your OT environment. So, of course, again, there's today more and more solutions that can be proposed as protection or security for OT. But here we want to bring up two specific solutions that are Storm Shield, okay, and SecLab. So for Storm Shield and SecLab, first Storm Shield. To make it short, Storm Shield, who is Storm Shield? Storm Shield is a wholly owned subsidiary of Airbus. So you know Airbus, the planes, very known. So Airbus has a lot of different things, but they have a cybersecurity part, and Storm Shield is again comes from there. So the decision maker, if I can say, in the end, are going to be Airbus. But Storm Shield again is a completely self-autonomous, you can say, entity. Okay, so they create their own firewalls, they create their own products, and what's important is that they create a dedicated model, a dedicated next-gen firewall for the OT. So you can see it here. Very small, very light, very secure, of course. And again, it's a specific model for OT. Wait, here. If you want to see it, if you want to touch it. So it's a specific model for OT. With, again, of course, all the norms, ruggedized firewall, resistance to dust, temperature, magnetism, everything. But I would say that's one thing, yes. But what's important is what is inside. So what you have inside, and it's going to be very important for the rest of the presentation, is that what you have inside is a stateful DPI. The stateful DPI on industrial protocol. It's very, very important because this is why you will have the main difference between Stormshield and another type of firewalls. In the industry, Stormshield is one of the only, if not the only, that is able to have the packet inspection, stateful the packet inspection on the OT protocols, Modbus, Ethernet, OPC, BACnet, IEC 104. You have a lot and a lot of OT protocols. Why you have these protocols? Why they are able to do that? Simply because Stormshield has partnership with a lot of OT actors like Schneider, Siemens, and so on. And again, it's going to make a big, very big difference. So what you can do is that, of course, Stormshield not only provide firewall for OT, they also have classic IT firewall. But the main goal of Stormshield is to provide a unified system. So what does it mean? It means that whether you have IT firewall or whether you have OT firewall, it's the same system, actually. It's the same system. And what you want to do with Stormshield, and again, it's going to be very important in IT, OT, or both at the same time, is to do what we call segmentation. Segmentation, you cut your network into parts so that if something has been breached, there's the hacker that can here, for example, in telemanagement, they cannot do lateral movements. They're stuck here, can't go anywhere. So, in an OT network, like in IT actually, so a hacker will be able to use vulnerability on the software, on the server, whether on the operating system, whether on specific software, and then we use it again to go left, right, and to try to get the full map of the network. So again, with Stormshield, whether you are in IT or OT, you will be able to segment your network, to isolate each part, to isolate each one of them, so that if there is a breach somewhere, in the workstation, for example here, or in the telemanagement, like I said, or in the SCADA system, then you completely block them from going everywhere. Exactly the same thing for the OT, what we call the OT micro-segmentation. So again, it goes even more further than just, for example, protecting a group of devices. We can even protect individually the different item from an OT environment. Okay? PLC, sensors, robots. So here we can use, so effectively it is the SNI for it. We can use that to do micro-segmenting and to analyze the traffic between the different systems. Again, why we can do that? Because we understand we have deep backend inspection on the different OT protocols. Again, Modbus, IEC 104, BACnet, OPC, and so on. What's very important, and probably you know that also, is that usually when you have systems like PLC, robots, etc., that are configured, you don't want to change the configuration. You don't want to change the network configuration. Usually, it's hard-coded. It is inside the configuration. You don't want to change the configuration. Well, with Stormshield, you can do it. You can implement storm sheets without touching everything, without touching the configuration. It's going to be something very important because, of course, if you implement a firewall and then you need to change the whole network configuration, it makes no sense. So here again, very important. So again, something very, very important. I repeat myself, but again, because it's very important, is that inside storm sheets, we understand the protocols. Okay? So let's say you're using Modbus to do whatever, and you send commands. Okay? You send commands through storm sheets. Storm sheet can analyze and understand the protocol. So we don't base the analysis, we don't base the protection on what we call signatures. You know, signatures is like an antivirus. There is an attack, they create a signature, and then if there's a new attack, the signature is the same, so the firewall will say, oh, okay, I recognize the signature, so I block. Here, no, we don't do that. We understand the protocol. So if there's something wrong inside the command, packet modification, IP spoofing, or command spoofing, or whatever happens inside, we see it. We don't rely on signature. Signature in OT, it's not reliable. It's also true in IT, by the way. We don't want to have it. So again, why we are able to protect? Because we understand it. Additionally, of course, it means that it protects you from zero-day attack as well. So zero-day attack that nobody detected yet. Through the DPI, we can recognize, block, alert, and of course, protect you, protect the system. Okay, so very, very important. The second thing that we want to present today is SecLab. So who is SecLab? SecLab comes from EDF, maybe you know them, maybe not. EDF is the national power company of France. They have more than 20 nuclear power plants in France. It's a very, very big organization. They deploy power plants worldwide. They have a lot and a lot of sites all over the world. So EDF, of course, they have a lot of needs because it's a very big company. They have power plants everywhere. And so, of course, they need to secure their own power plants. So to do that, instead of going to vendors, what they have is that they have a research and development team. From this research and development team, they have a cybersecurity team. And from this cybersecurity team, SecLab was created. So SecLab comes from people that were working as R&D for EDF. So they were working on a project for EDF for securing their power plants, their nuclear power plants. And then they say, okay, there's a lot of solutions, but there's no solutions that actually allow us to protect. So what do? Well, we create one. And from there, SecLab is born. So SecLab today, what they provide? So SecLab is now completely it's a self-autonomous company. And what they provide today? They provide what we call the secure exchange network. So what you have in there, so it's a box that you have here. Okay, you will be able to see it. What you have inside this box? What it does? So this box is what we call a bidirectional secure gateway. It allows you to connect two networks. Okay? So two networks in our context, IT and OT. So it allows you to connect two networks, and the specificity is that it's going to create what we call an air gap. It's called an electronic air gap between the two networks. So it means that you have one side, you have another side, and in the middle, you have what we call an electrical component. This electrical component is basically what we call an FGPA. FGPA is a card like this, electrical card, and this allows traffic to go in or out depending on the configuration. But it's electronic. It's not software. There's no software. It's completely electronic. And you cannot change the behavior. It is bird, it's physical bird. You cannot change. If you want to change, you need to remove, create a new one, and put it back. You cannot physically change the behavior. So usually, if you've been working in OT for a long time, usually the equivalent would be, for example, a data diode. It's not the same technology, but in the end, you have this kind of things. But again, it's not the same technology as a data diode. Okay. So as a reminder, what is a data diode? Data diode allows you to send traffic only in one direction, and you cannot receive any traffic back. Only in one direction. Here again, it's completely different. SecLab will allow you to have traffic in both directions, depending on the security policy that you have chosen. Okay? Right. What it does, additionally, we have, so SecLab also created what we call the Secure Exchange USB. So, okay, what's the main goal of this? You have a manufacturer. You have to update, or a vendor has to update a system. How you do? Usually, okay, your manufacturer is not connected to internet. Logical thing. So what happens is that the vendor comes to your manufacturer, has his USB with the update, goes into the system, plugs, and then updates. But more than half of the attack comes from USB. Infected USB. This is how Stuxnet started, with a USB. So this allows you to secure your USB. So you take that, it's this size, okay? This size, a bit bigger, but it's this size. Take that, plug it into the system, you plug your USB here, and you're secure. USB killer, rubber ducky, all of that, completely solid. Okay? And again, what happened inside the box? So, like I mentioned, inside this box you have three things, right? You have side one, gate A, what's called the gate A, you have the gate B, and the core, which is the electric component. So, how does it work? You can see this box, you can see this exchange network, like what you have on top. It's transport. So, for example, if you want to send data, you have the transport layer, so for example the truck, and the data inside. So what we do with SecLab is that when the traffic arrives here, okay, we say, okay, you stop, you give us the data, the boxes, and then we will recreate, we will send it through another transport, inside another transport, which is here, SecLab transport. So this is what SecLab is doing. We stop here, take the data, put the data in a new truck, and then send the data to destination. That's what we have with SecLab. Okay. Again, it's an electronic component, so you cannot modify the behavior. You can allow one direction, other direction, or two directions. It depends on what you configure. But what's important again is that in terms of protocol, we'll be able to manage TCP or UDP. If you're working with data diode, you know that usually, because it's one direction, you cannot work with TCP. Or you have to have like proxies or converters or whatever. So here with SecLab, we can manage TCP protocols like Modbus, IEC, everything that is HTTPS. Okay? So again, what happens exactly is that we take the packet, we remove transport layer, and then we send with a new transport layer based on SecLab. That's what happened for the protocol. Of course, you also have another part, which is file transfer. Because again, file transfer is one of the main attack vectors for an OT environment. When you have to update the system, this is where you get problems. And you don't want people to come with their USB and then plug it everywhere and kill all the system. So you have the ability to use file transfer to do that. Very important. So if you understood these two products, SecLab on the transport layer and StormShield on the stateful DPI of the protocols, you can understand that StormShield plus SecLab offers you a complete solution, offers you a complete protection. Why? Because again, with StormShield, you can understand the protocols. You understand the protocols. So if there is an attack inside the protocols, it's going to be stopped by StormShield. But of course, before the protocols, you have the transport. And in this case, if it's on the transport, on the lower layer, you have the protection from SecLab. So here SecLab, so again, Stuxnet, because you have protections from USB, you have protections from file transfer, HID attack, zero-day attack, bad USB, spec, in-destroyer, this kind of attack. And then StormShield again, because we understand the different protocols, can detect intrusion. We can, there is an anti-malware, so you can block malware. You can filter the network. Okay, so you have a lot of things. And again, the fact that you are using the two allows you to create a full security of layer 1 to layer 7. And this is used by SNCF. If you don't know SNCF, it's the national train company in France. They have the headquarters in France, but it goes all over Europe. And they use that to protect, of course, their critical infrastructure. How they do it? They have two firewalls, two StormShields, here and here. And what they want is to connect the IT to the OT. That's, again, Industry 4.0, we connect everything, blah, blah, blah. Same story. So, again, here, what we want is to have a clear air gap. Okay, what we call an air gap, again, is to have complete separation between IT and OT, but still, we still want connectivity. So again, we use one firewall in IT, one firewall in OT, and we connect the two with a SecLab. That's how they do it. Of course, there's a lot of use cases, there's a lot of different things. Okay. So that allows the IT admin, for example, if there is an update to do on the system, the IT admins can send a file, for example, can send the update on the SXM, and then the OT admin can come on the SXM and take the update to put it on the systems. So, you know, again, because you have two environments, you have IT admins and OT admins. They are completely different persons. So again, you can make it work like this. IT admins, Airbus has an update on the system, or Siemens have an update on the system. Download from internet, then send it through SXM. SXM will check signatures, encrypt, and then if everything is okay, send it to the other side. Then IT say, hey, OT guy, there is a new update. So OT guy, okay, I put it here, take the file, okay, file is good, put on systems. So no more USB, please. Less USB, that's it. Like this, you're able to manage correctly the systems. Okay, so that's only two solutions on what you can have inside the OT. There is actually one last one, and it's not in English because, well, it's not a surprise, but a bit. Have you ever heard about PAM, Privileged Access Management? Usually yes, and usually it's in IT. Yeah. But actually, with Walix, they have a solution for OT as well. They have a dedicated solution for OT. So again, of course, Walix certified. They have PAM, and here again, PAM is something that now you can apply to OT as well. When you want to connect, again, when you want to connect IT and OT, now, in addition to network security, firewalls, data diode, bidirectional gateway, you can also apply PAM. Why it is important? Because I told you before, all the technology is completely useless if you cannot control the people. If you cannot control the people, you can have whatever, if you have a direct access, that's it, it's the end. So, why PAM again? Because PAM allows you to control effectively people that will connect to the systems. For example, I'll take again the example, connect to SecLab, take the update, then go to system and update the system. Okay, but what happens if the guy tries to update the system and something goes wrong? This is where you will have the PAM. So with Walix, you have different things, you have different technology, secure remote maintenance. Again, Industry 4.0, everything connected. Remote maintenance will be something, will be a thing that you need to check. Endpoint privilege, you have a lot of workstation in OT, like Windows 7, even before 7. Very old systems, but you do have endpoints. Manufacturing credential protection. Again, you have OT protocols. You have to secure the OT protocols. And of course, because you have that everywhere, you have the regulation, the laws, regulation, directive, and so on. So Walix has a unique technology. They are the only PAM solution that propose that. They have what we call the universal tunneling. What is universal tunneling? Let's say, for example, here, same thing. You have workstation from IT, and you want to go to PLC, Schneider, Siemens, human interface. You want to go inside the OT. You can create a secure connection. Why secure connection? Remember, Modbus, Profinet, BACnet, ISE, they are not secure by default. If you take Wireshark and you scan the network where there's Modbus and so on, nothing is encrypted. It's all in clear. You can see the command, you can see the source destination, you can see everything. So what we want is to protect the connection again between the IT and it. So we'll create what we call a tunnel between here and here and send the data inside the tunnel. So if you want, same concept as a VPN, but a bit different, but same concept. Okay? And the thing is that inside Wallet, we'll be able to record, trace. Before opening a connection, a user will need to identify, authenticate. There can be MFA, for example. There can be a lot of things, and that's the main point. Okay. So again, that's an additional thing that you can have. It's quite new, I would say. It's a new concept because until now, what you had in OT was I use jump server. Use jump server in OT. That's not very good. Okay? So, right. So that's basically it. Again, you have Stormship, you have SecLab for the network, and then you have Wallet for the privacy. Okay? Thank you. We're going to have a break now, and we'll continue with the demo after the break. Thank you.
ครับเดี๋ยวก็เชิญร่วมสัมมนาทุกท่านเดี๋ยวเบรกกันสักพักนึงแล้วกันนะครับแล้วเดี๋ยวกลับจากเบรกมาอาจจะสัก11:15หรืออะไรอย่างเงี้ยครับเดี๋ยวผมจะมารีแคปเป็นภาษาไทยสั้นๆให้ฟังอีกรอบนึงนะครับว่าวันนี้เกิดผลพูดอะไรบ้างนะครับแล้วก็เผื่อมีข้อสงสัยอะไรก็สอบถามกันขึ้นมาได้นะครับแล้วหลังจากนั้นจะไปสู่เซสชั่นเดโมของเซอร์ตัวนะฮะโอเคเราเบรกกันก่อนนะครับเข้าห้องน้ำแล้วก็เดี๋ยวเรา
กาแฟมาทานข้างในได้
กาแฟอะไรอย่างเงี้ยมาทานข้างในได้แล้วเดี๋ยวข้างหน้าจะมีมีเยอะให้
มีสองลำก็อร่อยทานไม่ทานกับเขาไปทานข้างนอกไม่ได้ไม่ชอบเข้ามาเราจะกินกันได้เพิ่มแต่ทุกคนทานข้างในนะแต่อยากให้เขาได้ทานของอร่อยนะคะ
ค่าใช้จ่ายเกี่ยวกับอาหารที่บ้านตัวเล่น